For the other examples in 1.7, I'm just going to give you some hints on specific homework problems in your assignment. So we're going to start off with a hint on number 26 from page 149. It says, on their 560-mile trip, the Bruins basketball team spent 2 hours more on the interstate highway than they did on local highways. They averaged 45 miles per hour on local highways and 55 miles per hour on interstate highways. How many hours did they spend driving on local highways? Now, you'll notice here at the end it says D equals RT. That's not in your book, but I put that there because this is kind of a simple mathematical model for distance. So that means distance equals rate times time. The problems you're going to be working on today will, almost all of them will have some sort of a simple model like this that we're going to build from. So distance equals rate times time. So speed times time is going to give us the amount of distance we have here. And it says a 560-mile trip. But what we're really looking for in this problem is how many hours did they spend driving on local highways? And so we're going to make that our goal to find out what the number of hours on local highways is. That's a time. Now, one thing that's really important with these application problems that we do today is oftentimes to define the variables. That can really help out as far as the direction of the rest of this problem. So you'll notice here that I've defined the time on the local highways is just the variable t. Oftentimes the question that they're asking, if we keep that part the simplest, we'll be in the best shape. Now there's also time on the interstate because we need to take that into account that we went on the interstate and on the local highways 45 and 55 to get our total of 560. So I'm going to call that t plus 2 because it tells us here that they spent 2 hours more on the interstate highways. And so t plus 2 will make whatever time this is plus 2 hours. So now what we're going to do with this is try to use this distance model, d equals rt, to add up for their total trip that they have right here. Now, if I wanted to find the distance on the local highways, this is just the total trip, but if I wanted to go for the local highways, what I would do is, I would say distance equals rate times time. I don't know what that time is. I'm trying to find out the distance, but I do know that on the local highways they average 45 miles per hour. So I'm going to say 45 times t, whatever t happens to be. Now in a very similar way, I'm going to do the model for the interstate highways as well. Interstate highways were 55 miles an hour, so I'm going to do rate as 55 times the total amount of time, which we define that variable as t plus 2. Now they don't give us the distance for either of these individually, but they do give us the total distance for this trip. So knowing that we have a total of 560 miles, what we can do is add this expression and this expression equal to 560, and then it's a matter of just solving that equation for t. You should be able to find out the time on the local highways. That'll also give you the interstate time, but you want to set up an equation, solve for t. That will get you the rest of the way on this problem.